Hello students, my name is Rishabh Anand. I am physics faculty from Perfect Academy. So today we will be dealing with center of mass chapter and we will go through the problems while doing this. Okay, so let's go with first problem, and suppose that I take axis and two particles, one moving with velocity v and that has mass of n into m. Another particle of mass m moving with velocities v. Okay, so how will you write velocity of center of mass? That means velocity of center of mass is what? Okay, we know that VCM we write as m1 v1 plus m2 v2 upon m1 plus m2. This particle of mass nm will be moving with some angle theta with respect to x-axis. That means we can write velocity of this nm mass in terms of I vector and j vector. That means we can write velocity of nm mass, and we say that is v1 is v cos theta I plus v sin theta j. Okay, now for this mass, say v2, that is velocity of m mass, is v cos theta I cap. Okay, now we will write here m1 is mass of nm, that means nm v nm plus m2 is mass m into v2 is vm upon m1 plus m2. Okay, and m1 plus m2 you can write as nm plus m m1 plus n. Okay, now this nm into vnm will be nm v cos theta I cap plus v sin theta j cap plus m v cos theta I cap. Sorry, mv I cap. v2 is only v, sorry for that, v I cap. Okay, that mass was m moving with along x-axis only, so v I cap. Okay, now upon m1 plus n. So simply by writing all the velocities in terms of x and y, we can separate I cap and j cap, which will be the velocity of center of mass along x-axis and along y-axis. So finally this you will write, if you collect I cap term here and here, it will be mv cos theta, okay, right here, n mv cos theta I cap plus mv I cap plus nm v sin theta, nm v sin theta j cap upon m into 1 plus n. Okay, so in this way you found VCM in terms of this VCM in terms of VCM along x-axis plus VCM along y-axis. Okay, let's move on to next question. Here we will, next question, let's deal with acceleration of center of mass. And let's see how to take different frames. Like if I say this is inclined plane surface, and this is having angle 60 degree, and this having angle 30 degree. Here A having mass m and block B having mass m. Okay, now they are going down. They will have their own acceleration. Now you have to find acceleration of center of mass is what? Okay. Now again see, if this is 30 60, this will be 90. That means we can take axis as this. This will be x-axis and this will be y-axis. Axes are mutually perpendicular. Okay. So as we define this x and this y, so along x we have acceleration for A, which is g sine 30 degree. So g sine 30 degree I cap. Along y-axis for B, it is g sine 60 degree j cap. Right? Now we write again A center of mass as m1 a1 plus m2 a2 upon m1 plus m2. Now m1 having same mass, so m A is g sine 30 I cap plus m g sine 60 j cap upon m plus m. This will be g by 2 sine 30 I cap plus g by 2 sine 60 j cap. Okay, so again this total term will be A along x plus A along y of center of mass. Okay, similarly, so sine 30 1 by 2, so g by 4. So g by 4 I cap is A of x of center of mass. Okay, then g by 2 and root 3 by 2. So root 3 g by 4 j is ay of center of mass. Okay. Now, as we know that we write F net is m into A cm. Okay, when net external force becomes 0 for system, then we can say that A center of mass is 0. That means either velocity is 0 or velocity of center of mass is constant. Both we can write. Okay, so let's see how to take examples of this and this part when they are moving with constant velocity and 0, or center of mass is at rest or moving with constant velocity. Okay, one problem is, suppose a plank is there of mass m. Okay, a man is there standing on plank of mass m. Okay, now that plank is kept on a frictionless surface. Okay, for this frictionless surface mu is 0. Now, so here will be somewhere, here is the L by 2 part where the plank center of mass will be there, but because of this mass here, so center of mass will be somewhat here. Okay, somewhere here for man and Planck system. Man plus Planck system. Okay. Now, what will happen? As the question is, find displacement of Planck as the man reaches other end. So now man is going to the other end. Okay. So what will happen when the man will reach the other end? If this is the line of center of mass, this one, okay, and when man will walk, there will be friction on both, on man and Planck. So again, as a system, when you look as a system of man and Planck, that frictional force becomes internal force. That means again F external is 0. When F external is 0, that means either center of mass will be constant, velocity having constant, or it will be at rest. Here, initially, man and Planck was at rest. So center of mass will be at rest, right? Now, as the man will reach here, so situation will be like this. Man will go forward, this Planck will come backward. So at a point, it will be like right? Man reaches here while walking, and this center of mass shifts here, okay, along the same line. Here was the center of mass for Planck. That means if you say Planck has gone backward by x, suppose distance traveled by Planck is x backward, okay, that means when center of mass remains at rest, that means you can write delta r of center of mass as 0, okay. So from center of mass formula, m total into delta r cum is m1 delta r1 plus m2 delta r2, okay. That means if Planck is going backward by x, that means if I say m1 for the Planck, so m delta r1, displacement of Planck is x towards negative direction. If I take this as positive and this as negative direction, so backward means negative, so minus x plus m2, that man of mass m is going L minus x in positive direction. Delta r cum is 0, so this will have 0 value, and then again m into x will be m L minus x. That means x will be m into L upon m plus m. That is, Planck is going backward by this distance. Okay. Now let's say when VCM is constant, when center of mass moves with constant velocity, there we can take the situation of explosion of a cannon. Listen, one case, suppose a cannon is fired, okay, from A point, a projectile is fired in this way, having initial velocity v and angle theta. Okay, now situation is this initial. Okay, now it is said that at highest point the projectile breaks into two equal parts. Okay, two equal parts. One part retraces its path back to A. Okay, the speed of other part is what? That means a shell of mass m was fired with velocity v and angle theta. At the highest point, what happens? It breaks into two parts. One part retracing back to A, right? Suppose it is having v1 velocity, other part is going with some v2 at the maximum height. Okay, so they are of equal mass. That means you can take m and m. Now, explosion is because of internal forces. Whatever internal energy is lost, they break apart. There is no external force in that. So again, when no external force, center of mass will have same velocities. Okay, constant velocity. That means at highest point, it was having v cos theta. That means 2m mass was going with v cos theta when it gets explosion. Okay, now that means you can write m total into v of center of mass equals m1 v1 plus m2 v2. Okay, this mass m retracing the path means this will return back with the same velocity v cos theta, then only it will go back to A, because on x-axis there is no acceleration. Okay, only in y-axis there is acceleration equal to g in the projectile motion. So m total is 2m. Center of mass velocity was v cos theta before explosion, so v cos theta. If I say m1 going backwards, say m going backward means v cos theta with minus sign plus m2 into v2. Okay, now with this we will get that m into v2 is 3m v cos theta. Okay, now if you cancel it, you will get velocity of other mass as 3v cos theta. Okay. Let us look into a new concept of conservation of momentum. We know that F external we write as ma of center of mass. Because if I take any particle, okay, and several forces are applied, so we choose a center of mass, and on that we apply net force, and that net force from second's law of motion is MACM. Okay, if this having mass m, so that ACM, that acceleration, is for center of mass. That is why this you write. And you know that force is rate of change of momentum. That means you write d upon dt of mvcm, because that center of mass has velocity. Okay, so m d vcm upon dt. Okay, this we can write as force. Now, when external force becomes 0, when F external becomes 0, there may be internal forces. Okay, there may be internal forces between two particles, say interaction. Interaction forces, they add up to 0 when you take all the particles here. Okay, so internal forces may be present, but net external force is 0. Then you can say that m Vcm upon dt is 0. Also you can say that dp upon dt is 0. When dp upon dt is 0, you can say that p is constant. That means you can write p1 equals p2 equals p3 for a system. For a system. Remember, only for system. See, because what happens if I take example, say this two balls, one having 2 kg mass and one having 4 kg mass. One is moving at 2 meter per second and one is moving with 4 meter per second in this direction. When you see as a system, no external force is there, and momentum you write for this system as 4 into 8, right? 8 kg meter per second, and thus negative sign minus plus of 4 into minus 2 kg meter per second. So as a system they are having momentum 0. For as a system momentum is 0, but individually when you write individual, it has momentum of 8 kg meter per second. This also has minus 8 kg meter per second. So individually they have momentum, but as a system, when net force is 0, they may be attracting towards each other because of mutual attraction forces, or maybe some internal forces. We cannot see any external force here, right? So for a system it is 0 or momentum is conserved, but individually they have their own momentum. Okay, so and when you see this, this is what you call conservation of momentum. That means for isolated particles or isolated system of particles, total momentum is conserved. P is constant when net external force is 0, dp upon dt is 0, that means momentum is constant. So you can write initial momentum. Also one definition for this conservation of momentum is initial momentum equals to final momentum for system. Okay.